What if blockchain wasn't another database to rip and replace, but a trust layer that anchors everything you already run? In this course, you'll learn a practical blueprint for hybrid enterprise blockchain, what belongs on-chain, off-chain, and on sidechains, and how to architect that balance in real systems. Many enterprises assume blockchain will replace their existing systems. In practice, the most successful pattern is very different. Blockchain works best as middleware, not as a new database. Your current Web 2.0 stack still manages users, applications, and primary storage. Blockchain sits underneath as a shared integrity layer that multiple systems can rely on. It records critical proofs, agreements, or value transfers in a way that no single party can silently change. This hybrid model keeps performance and privacy in your existing stack while adding verifiable trust precisely where it creates business value. Designing a hybrid enterprise blockchain always comes back to one hard question: where should each piece of data live? Every decision pulls on three competing goals. Scalability asks, can the system handle high volume at low cost and latency? Privacy asks, can we protect sensitive or regulated data and still comply with rules like GDPR? Decentralization asks, can we avoid trusting any single party's database and instead anchor truth to a shared ledger? You can't fully maximize all three. Good architecture is about conscious trade-offs, deciding which data and computations stay on-chain and which move off-chain or to sidechains. Let's zoom into Pillar 1, the on-chain layer, your trust anchor. Think of it as an immutable vault. You only place what absolutely must be tamper-proof and globally verifiable. That includes cryptographic fingerprints of data, not the data itself, core business rules as smart contracts, and actual value transfers, like tokens or settlement records. Because blockchains are expensive and slower, you deliberately keep bulky, sensitive, or noisy data off-chain. No personal information, no large media, no high-frequency telemetry. By being this selective, you maximize trust while keeping cost, performance, and compliance under control. Next is Pillar 2, the off-chain performance engine. The chain is your narrow, trusted spine. Off-chain is where most real work happens. Here you store the bulk of data in fast, inexpensive systems like SQL databases, cloud storage, or decentralized options such as IPFS. Event listeners and oracles watch the blockchain, react to smart contract events, and synchronize state back to enterprise systems. Heavy analytics, AI models, and multi-step business rules execute in trusted compute environments here as well. The objective is straightforward: keep integrity anchored on-chain while pushing volume and complexity off-chain for speed and scale. The third pillar of the hybrid architecture is sidechains. Think of sidechains as auxiliary blockchains that take over heavy execution, while the main chain remains the ultimate source of truth. High-frequency actions like IoT events or rapid micropayments can run on a sidechain without flooding the main network. Private sub-processes such as detailed supply chain steps can also live here, out of public view. Relay bridges periodically anchor sidechain block headers back to the main chain. That anchoring prevents double spending and lets you prove what happened on the sidechain without copying every transaction onto the main ledger. With the three pillars in mind, let's compare how they behave in practice. On-chain gives you the highest trust, but it's expensive and slow, so you reserve it for final settlement, tamper-proof proofs, and core governance logic. Off-chain is the opposite. You're trusting a server, but you gain low cost and high speed, ideal for PII, large files, and complex application logic. Sidechains sit in the middle. They usually follow a consortium model with medium trust, medium cost, and hybrid speed, making them well-suited for microtransactions, bursts of activity, and anything that needs serious scale. Here's how the hybrid pattern actually runs in production. A business action hits your normal backend. The backend writes detailed data into off-chain storage, then uses its logic layer to decide what must be anchored on-chain. It sends a minimal signed transaction through an API gateway and Oracle service to the blockchain, where a smart contract updates on-chain state and the ledger. That contract emits events. An event listener inside your backend subscribes to those events and updates SQL or triggers workflows. Your systems remain the system of record. Blockchain becomes the tamper-proof audit spine underneath them. GDPR creates a paradox. Blockchain data is permanent, while users must be able to delete their data. The way through is privacy by design. Keep all personally identifiable data in controlled off-chain storage. On-chain, store only a cryptographic hash of that data. The hash proves the data existed and wasn't tampered with, but reveals nothing by itself. When a user invokes the right to be forgotten, you delete or revoke the off-chain record or key. The on-chain hash then becomes a ghost pointer, still useful for audit trails, but practically impossible to link back to personal information. Designing governance for an enterprise blockchain is really about choosing who can join, who can write data, and how changes are approved. Public chains are open and permissionless, great for transparency, but risky for regulated data and harder to control. Private chains are fully controlled by one organization, which boosts speed and confidentiality, but recreates old centralization problems. Consortium networks sit in the middle. A group of known organizations share control under agreed rules. For security, integrate with your existing identity and access management, and use whitelisted smart contracts so only approved nodes and applications can participate. Architecture decisions always come back to a simple question: where should this data live? Start by asking, is it personally identifiable or highly sensitive? If yes, keep it off-chain in a private encrypted store and only anchor a hash on-chain if needed. If it's not sensitive, ask, does it represent value transfer, like balances, asset ownership, or critical state? Those elements belong directly on-chain as tokens or key contract state. Everything else is usually operational exhaust. When it's high frequency and low value, push it to a sidechain or similar scaling layer and batch or summarize to the main chain only when necessary. To future-proof a hybrid enterprise, your blockchain can't be an island. You'll often run a consortium chain for privacy and control, but still need to connect to public networks for liquidity, broader verification, or ecosystem access. Interoperability bridges, such as relay chains and hash time-locked contracts, allow assets and proofs to move safely between these environments, without trusting a single intermediary. Design your integrations around standard APIs, so different chains, vendors, and services can be swapped out over time. Then use atomic swaps to exchange value across chains without custody risk, keeping assets portable and avoiding long-term vendor lock-in. Migrating to a hybrid blockchain architecture should feel like a staircase, not a cliff. Begin by defining value. Where do trust, auditability, or multi-party coordination really matter in your business? Next, map the process and clearly separate audit data from user data. That separation lets you design clean on-chain and off-chain boundaries. Then, run a small pilot focused on low-risk audit logs to validate your assumptions. Once that works, integrate with your existing systems using middleware and APIs. Only after these foundations are solid do you scale into value transfer and smart contracts, where real economic impact appears. Let's wrap the blueprint into 5 habits you can actually use. First, always minimize on-chain data. Anchor with hashes, keep real payloads off-chain. Second, design everything to be event-driven. Let contracts emit events and listeners react. Avoid constant polling. Third, treat privacy as non-negotiable. Keep PII off-chain and rely on ghost hashes so deletion remains possible. Fourth, lock in consortium governance early. Define IAM roles, node policies, and who can deploy what before you write code. Finally, security. Standardize on audited contracts, use proxy upgrade patterns, and assume every public interface will eventually be abused. You've now seen how blockchain can act as a trust anchor, not a database killer, and how hybrid architectures let you scale without sacrificing privacy or control. The real value appears when you map these patterns onto your own workflows. Which processes suffer from low trust, opaque auditing, or complex multi-party coordination? Those are your first candidates. From there, start small, design event-driven, and keep sensitive data off-chain. If you'd like support shaping a concrete blueprint, from pilot selection to governance design, reach out, and we'll work through your specific stack, constraints, and roadmap together.